Section 2.4, Relations. First, let's define a relation. A relation is any set of ordered pairs. And remember that an ordered pair is always the x value and then the y value. Okay? So we have several ordered pairs. And remember that ordered pairs can show up in different ways. You can have a list of ordered pairs. You can have a graph which represents all of the ordered pairs of an equation. So the x values you need to know are the domain values. The set of all the x values is called the domain. The set of all of the y values is known as the range. Now that we've defined a relation, let's talk about a specific type of relation known as a function. A function is a relation in which each element of the domain corresponds to one and only one element of the range. Remember that when we're talking about domain, we're talking about x values. So each x value corresponds to one and only one y value. Okay, every x is paired up with one y value. Now, let's take that definition and rewrite it a couple ways. What that really means in simpler terms is that we have no repeated x values. All right, no repeated x values. So for example, if we have the ordered pair 2, 5, we cannot have 2, 7. All right, 2 is already corresponding to 5, so 2 cannot correspond to 7. If you're looking at the graph and trying to determine if it's a function or not, you have to make sure that it passes the vertical line test. And when we get into some examples, we're going to look at graphs and determine if they are functions based on the vertical line test. All right, lastly, let's talk about function notation. You have seen it before, but I want to make sure you guys understand. Previously, when we looked at an equation, for example, y equals 2x plus 1, all right, we had our x and our y, we had our domain and our range values. Now, instead of using y, we're going to use f of x. That is function notation. F of x is equal to 2x plus 1. All right, it means the same thing as y. We're just stating that we have a function of x, meaning we're plugging in x values and we're going to get y values out. Now we're going to look at a few examples and determine if what's given is actually a function or not. So remember, determining if it's a function or not, we need to see if there are repeated x values, and if they give us the graph, we want to determine if it passes the vertical line test. Well, here we have a set of ordered pairs, -1, 2, 1, 3, 5, 2, and -1, -3. In order to determine if this is a function or not, remember we're trying to see if there are repeated x values. Well, right here we have an x value of -1. Over here we have another x value of -1. Remember that each x value or domain value can correspond to one and only one y value. So over here, since it already corresponds to 2, it's not allowed to correspond to another y value. So this, in fact, is not a function. Example 2. Determine whether the following defines y as a function of x. Okay, so we have this little flow chart. Over here, we have our x values, and over here we have our y values. Now, notice that we have these lines connecting x values and y values. So we could write these out as ordered pairs. So -2 as the x value is corresponding with 1. So we have the ordered pair -2, 1. -1 is corresponding with -3. 0 is corresponding with 2. And 2 is corresponding with 1. So I just want to make sure that you understand how to read this flow chart. Basically, they've given us a set of 4 ordered pairs. Now, to determine if it's a function or not, we need to look at the x values. We have -2, -1, 0, and 2. Since we have no repeated x values, this is a function. Example 3. Determine whether the following equations define y as a function of x. So this time we're given the equations. We're going to look at the equations and we're going to graph them to make our lives a little bit easier. This first one, x equals y minus 1. Well, I know from previous sections that I want to get y by itself. I want the equation to be y equals something in order to see what the equation is going to look like and in order to graph it. So what I'm first going to do is I'm going to add 1 to both sides. So that gives me x plus 1 equals y. Now I know I can rearrange that, put the y on the left-hand side, so I really have y equals x plus 1. And for function notation, I'm going to rewrite it as f of x equals x plus 1. Now, think about, you can just kind of start and make a table. When you're plugging in x values, let's pick some random x values. When you plug in, say, 2 into this equation, 2 plus 1 equals 3. All right? Are there any times when I'm going to plug an x value in and I'm going to get different y values? Okay? Sometimes it's hard to tell. In this case, it's pretty easy. So you could figure out if it's a function or not by just listing out some points and seeing if x values are going to give you more than one y value. But graphing actually makes your life a little bit easier. F of x equals x plus 1. We know this is a linear equation. This plus 1 tells me my y-intercept is 1. All right? And my slope is 1. So from that point, I'm going to go up 1 over 1. Let's see if we can get it to work. Nope. All right. We're going to go up 1 over 1, up 1 over 1. Then I know that this is the equation of a line with a slope of 1 and a y-intercept of 1. Now, using the vertical line test, is there anywhere on this graph that I can draw a vertical line, so straight up and down, and it's going to pass through the graph more than once? Nowhere. Okay, I can draw as many vertical lines as I want, and I'm not going to pass through that graph more than once. So that tells us that this is a function. Continuing on with example 3, we're going to do B. Notice there was a mistake on the screen previously, so your equation should be x squared plus y squared equals 9. Now, you might not recognize this equation, but this is the equation of a circle with a center at 0, 0 and a radius equal to 3. Okay, so I already have it drawn down here, so I just want you guys to recognize that this is going to be a circle. Now, I can clearly see that this is not going to pass the vertical line test. When I draw a vertical line, I'm clearly passing through 2 points. So I know right off the bat that this is not a function. Okay, now let's look at y. Let's pick an x value. Let's pick x equals 1. So when I plug 1 in, I get 1 squared plus y squared equals 9. Now, 1 squared is 1, so 1 plus y squared equals 9. Subtract 1 from both sides, I get y squared equals 8. To solve that, I know that I'm taking the square root of both sides. So when I do the square root of both sides, remember I need to take into consideration the positive and the negative outcomes. So y is equal to plus or minus root 8. That means I have 2 ordered pairs. I have the ordered pair 1 and positive root 8, and I have the ordered pair 1 and negative root 8. So mathematically, doing the algebra, I see that 1 is corresponding to 2 different y values. So looking at it in that perspective, I see it's not a function. or I could just simply do the vertical line test on the circle and see that it's not a function. Example 4, determine whether the following equations define y as a function of x. So very similar to example 3, we are given these equations and we have to determine if they're functions or not. Remember, we can look at the ordered pairs and see if there are repeated x values, or we can view the graph and see if it passes the vertical line test. So this first one here, let's just pick an x value and see what happens. All right, I'm going to pick x equals 5. And again, it doesn't matter what you start with, okay, or what x value you pick. Let's see what happens when I plug in an x value of 5 into here. That gives me the absolute value of y is equal to 5 minus 4. I know 5 minus 4 is 1. So absolute value of y is equal to 1. To solve this, I know that when I have absolute value, I have to set up two equations. That's going to give me the equation y equals 1 and the equation y equals negative 1. So I see right off the bat that that 5 corresponds to two different y values. Okay, so I already know that it's not a function. Now, just so you know, the graph of an absolute value of y is going to be a V turned on its side. So this graph actually looks something like that, okay? And we can tell that it does not pass the vertical line test. Now, moving on to example B, x equals y squared. Again, you can pick an x value, okay? I'm going to pick x equals 16. When I plug 16 in, I get 16 equals y squared. How do I solve that? Well, I take the square root of both sides. Square root of y squared is equal to the square root of 16. But remember, when I'm taking the square root of a number, I have to do plus or minus. So y is equal to positive or negative 4. All right, again, that means that we have the ordered pair 16 positive 4 and 16 negative 4. All right, again, I have repeated x values. So this one is not a function. All right, and just to give you an idea of what the graph looks like, kind of similar to the example part A, we know that if it was x squared, it would be a parabola, okay? Y squared is also parabola, but it's turned on its side, okay? And again, we can visually see it does not pass the vertical line test. So both of these are not functions of x. Example 5, let f of x equal x squared minus 3x plus 1. We're going to find each of the following. So this is making sure that we understand function notation. So f of 2 is simply telling us to take 2 and plug it into the equation wherever we see an x. So f of 2 is going to be equal to 2 squared, again I'm plugging a 2 where I see the x, minus 3 times 2 plus 1. And then I'm just going to simply simplify. 2 squared is 4, minus 3 times 2 is 6, plus 1. 4 minus 6 is a negative 2. Negative 2 plus 1 is negative 1. All right, so just to make sure you guys understand this notation, that's just saying that, hey, we have the ordered pair 2, negative 1. When I plug in a 2, I'm going to get negative 1 out. That's what this f of 2 is telling us to do. Part B wants us to find f of negative x. So again, that's just telling us, this right here is telling us what to plug in. So we're going to plug a negative x wherever I see an x. That's going to give me negative x squared minus 3 times negative x plus 1. Remember, this is where people make a mistake. A negative squared gives us a positive. So I have positive x squared. a negative 3 times a negative x is a positive 3x. And then I have plus 1. So when I plug in negative x, it gives me x squared plus 3x plus 1. That is my answer. Now, part C says find f of x plus 3. That means wherever I see an x, I'm going to plug in x plus 3. So this one is a little more complicated. All right, I see an x, I'm going to plug in x plus 3 squared minus 3, and I see another x, I'm going to plug in x plus 3, and then I have plus 1. Now I need to simplify that. In order to simplify that, remember that this x plus 3 squared really means that we have x plus 3 times x plus 3. And then we have minus 3 times x plus 3 plus 1. So don't forget that this x plus 3 squared means we have an x plus 3 times an x plus 3, and we have to FOIL that out. So when I FOIL that out, I get x squared plus 3x plus another 3x plus 9. And now when I distribute this negative 3 to both terms, I get minus 3x minus 9 plus 1. Now I need to go ahead and combine like terms. So I have just one x squared, so x squared. Let's look at my x's. I have 3x plus 3x, which is 6x. And then I have a minus 3x over here. So 6x minus 3x is going to leave me with 3x. And then I have a positive 9 and then a minus 9. So positive 9 minus 9 is 0. But then I have this plus 1. So I'm left with x squared plus 3x plus 1. And that is my answer. Example 6, let f of x equal 2x squared plus 4x minus 5. We want to find all x values such that the ordered pair x comma 1 is on the graph of f. So first we got to understand what this is talking about. They're saying, hey, the y value is 1. If the y value is 1, we need to figure out what the x values would be. Okay? So what I'm going to do is I'm going to plug in 1 for y. You're like, where's the y? Well, remember that y, we're not using y, we're using f of x. So we're going to plug in 1 for the f of x. All right? So I'm going to write it over here. We have f of x equals 2x squared plus 4x minus 5. And again, it says, okay, we're going to plug 1 in for that f of x. So it's going to become 1 equals 2x squared plus 4x minus 5. Okay, again, we know what the y value is, or we know what the f of x value is. Now, this goes back to what we worked on during exam 1. How do I solve for x? Well, the first thing I need to do is I need to get everything on one side. So I'm going to subtract 1. That's going to leave me with 0 equals 2x squared plus 4x minus 6. All right? When I have something like this, I know it's a quadratic. I have two ways to solve a quadratic. I can factor, or I can do the quadratic formula. I personally prefer to factor, so I'm going to go that route. When you're factoring, the first thing you always look for is a greatest common factor. I see that all of these are divisible by 2. So 0 equals, I'm going to factor out a 2. That leaves me with x squared plus 2x minus 3. All right, just to simplify my life, I'm going to go ahead and divide that common factor out. Divide both sides by 2. I see that they cancel out on the right-hand side. 0 divided by 2 is still 0. So 0 equals x squared plus 2x minus 3. All right. Now, you can factor on the side. I'm not going to take the time to do that, but you can do the grid that we've been doing, set up the boxes. But the factors of this are x plus 3 and x minus 1. All right. Remember, once I have them factored and I have it equal to 0, I can set each factor equal to 0. So x plus 3 could equal 0, or x minus 1 could equal 0. Okay, so I'm coming up here. Subtract 3 from both sides. That's going to give me x equals 3 is one possibility. I'm going to add 1 to both sides, and that's going to give me x equals 1. All right, so find all x such that x comma 1 is on the graph. I found my two x values, 3 and 1, so I actually have two solutions. Looking back, I see I have a little mistake over here. X plus 3 equals 0. I subtracted 3 from both sides, and that means really I should have a negative 3. So my answer should be negative 3 and positive 1. Sorry for that, guys. Now that we've defined what a function is and looked at function notation, let's talk about the domain and range of a function. The domain is the set of all possible x values. Keyword, all possible x values. Okay? Sometimes we're given a graph and we have to find the domain of a graph. So visually, we'll look at all the x values. And then other times, we're going to be given an equation, and we have two rules. The first rule is that we cannot have 0 in the denominator. If we have 0 in the denominator, we know it makes it undefined, so we have to exclude that value from the domain. The second rule is that the radicand cannot be negative. When I'm talking about radicand, I'm talking about what's in the square root, okay? What's in here. I can't have a negative because I know that gives me an imaginary number. It gives me that I. So again, we're trying to make the denominator not equal 0 because we don't want it to be undefined, and we don't want negative radicands because we don't want imaginary numbers. Those are our two rules for finding domain of an equation. And then we have range. The range is a set of, again, all possible y values. Example 7, find the domain and range of the function shown in the graph. We're going to write our answer in interval notation. All right, so remember, when we're talking about domain, I'm going to write it up here, domain is all possible x values, and range is all possible y values. So not just the ordered pairs they have plotted, but all possible x values and y values. So domain, we're looking at from left to right. Left to right. What is the lowest x value on this graph? Negative 2. Again, from left to right. So negative 2 is the lowest, and then my highest x value on this graph is 3. All right, so I'm going to write that as negative 2 to 3. Now, for interval notation, we have to decide if we're going to have parentheses or brackets. Well, notice this negative 2 is an open circle, an open dot. So I know that that negative 2 is going to get a parenthesis. Now, this 3 is a closed dot, so it's going to get a bracket. So all x values from negative 2 to 3, including 3 but not including negative 2, are in the domain. That means values like 0, 1/2, negative 2.5, I'm sorry, negative 1.5. All of the values between negative 2 and 3 are included. So that is my domain. Now let's look at the range real quick. Range, remember, is the y values, okay? So we're going to go from bottom to top. So what is the lowest y value that this graph hits? 1. And what is the highest y value? 4. So my range is going to be from 1 to 4. And again, I have to see if they're included or not. Well, the 1 gets a bracket. Sorry for the random mark. There we go. The 1 gets a bracket. I'm sorry, a parenthesis. And the 4 gets a bracket. So my range is all values from 1, not including 1, to 4. Example 8. Find the domain of the following function. Write the answer in interval notation. So we're going to dive into finding the domain of an equation. So if you refer back in your notes, remember, if we are given an equation, we have 2 rules that we have to look at. The first one is we have to look at the denominator. The denominator cannot equal 0. And the second rule is that the radicand has to be greater than or equal to 0. So we look at this and we say, okay, well, we don't even have a denominator, so we don't have to worry about that. But we do have a radicand. And remember, the radicand is what is under the radical. So my 2x plus 7 is the radicand, and I know that that has to be greater than or equal to 0. I cannot have a negative in the radicand. So I'm simply going to solve this. I'm going to subtract 7 from both sides. That's going to give me 2x is greater than or equal to negative 7. Divide both sides by 2. So I'm left with x has to be greater than or equal to negative 7/2. All right? Yes, that is the domain, but it clearly states that I have to write it in interval notation. So how do I write x is greater than or equal to negative 7/2? So just a little refresher of what we did with inequalities before. So if negative 7/2 is right here on my number line, all right, negative 7/2 is greater than or equal to. Greater than or equal to means I'm going to get a bracket and everything in this direction to the right. Okay, greater than or equal to negative 7/2. So sometimes graphing it out is going to help me see what the interval notation should look like. So my interval notation is everything from negative 7/2, including it, to infinity. And remember, infinity is always going to get a parenthesis. So my interval notation is bracket, negative 7/2 to infinity. Example 9. Find the domain of the following function. Write the answer in interval notation. So very similar to example 8, except we have a different function now. Recall, our 2 rules are, 1, to look at the denominator. Do we have a denominator? Well, there's nothing. There's no denominator, so we don't even have to worry about that rule. And the second rule is to look at the radicand. Do we have a radical in this problem? No. So again, our 2 rules don't even apply to this, okay? So we have no exclusions. So there are no values that we have to exclude from the domain, which means every value can go into this function and produce a y value. When there are no exclusions, my domain is simply negative infinity to infinity. All real numbers. Example 10. Find the domain of the following function and write the answer in interval notation. Okay, continuing on. Remember, we're looking at 1, the denominator, and 2, the radicand. First question is, do we have a denominator? Absolutely. My denominator is x squared minus 4. And I know that the denominator cannot equal 0. Okay, so let's work with this first. How do I solve this? Well, there's a couple different ways, okay, and I'm going to show you both ways just so you have options. The first is to simply get the x by itself. So to do that, so here's one way. X squared minus 4 cannot equal 0. Think about this as just an equal sign for now. I'm going to add 4 to both sides. That's going to give me x squared cannot equal positive 4. To solve that, remember I'm going to take the square root of both sides. Remember that when I take the square root of a number, I have to take the positive and the negative. So that's going to leave me with x cannot equal, square root of 4 is 2, so x cannot equal positive 2 and negative 2. Now, again, I'm going to show you just another way. Some of you would recognize that this x squared minus 4 is a difference of squares. Well, you would go ahead and factor that. The factors of a difference of squares are going to be, in this case, x plus 2 times x minus 2 cannot equal 0. Again, we're kind of assuming or looking at this like an equal sign. Once I have it factored and I have it equal to 0, I can set each factor equal to 0. So x plus 2, don't really need the parenthesis, let me get rid of that so I don't confuse you. X plus 2 cannot equal 0, and x minus 2 cannot equal 0. When I solve this x plus 2 cannot equal 0, and I subtract 2 from both sides, that's going to give me x cannot equal negative 2 as one piece, and this one's going to give me x cannot equal positive 2. So no matter which way you do it, okay, this first way was the square root method, the second way was factoring, you're going to get two values that are excluded from the domain. Now, we have to go back up here to our second rule. It says we have to check to see if we have a radicand. Well, we don't have a radical in this problem, so I don't even have to worry about this second rule. Now, what I have to do is I have to take my answer and write it in interval notation. So I'm saying all values except 2 and negative 2. So I have to exclude 2 and negative 2. Okay, everything else works. So here's how you write that in interval notation. All right, I want all values, so I want everything from negative infinity up to my first exclusion. The first exclusion that comes up is negative 2. I stop there and I pick back up. Union. Okay, so everything from negative infinity to negative 2. Wherever I pick back up, wherever I left off, I pick back up. So I'm going to go from negative 2 to my next exclusion, which is 2. And then union, wherever I left off, I pick back up, which was 2, and I keep going to infinity. So let me write that a little neater down here. That's everything from negative infinity up to 2. Up to negative 2, pick back up, negative 2 to 2 is the next cutoff, pick back up, 2 to infinity. So that is the domain of this function. Example 11. Find the domain of the following function, write the answer in interval notation. So again, I have to look at my two rules. First rule is the denominator. Okay, so I have to take whatever's in the denominator, which I have this time, which is 1 minus x, and I know that cannot equal 0. So let's work with that part first. All right, some of you may subtract 1 from both sides. I'm just going to go ahead and add x, so I only have to do one step. So 1 cannot equal x, and I don't like it that way, so I'm going to write x cannot equal 1. So that's one part of my domain. All right, step 2 says to look at your radical. Well, I also have a radical in this problem. So the radicand, which is what's under the square root, which is x plus 3, I know has to be greater than or equal to 0. So when I solve that, I have x has to be greater than or equal to negative 3. So I have two pieces that I need to put together. All right, for my domain, x cannot equal 1, and x has to also be greater than or equal to negative 3. So let's start at the lowest value. X has to be greater than or equal to negative 3. So that means everything from negative 3, including negative 3, so that's why it gets a bracket. It would be up to infinity if it were just this piece, but it's not. We have to exclude the value of 1. So I'm going to do everything from negative 3 to 1. 1 is excluded, so it gets a parenthesis. And then I have to pick back up where I left off. So union, pick back up at 1, and keep going to infinity. So my domain is from -3 to 1, excluding 1, and then 1 to infinity, also still excluding 1. Example 12. Find the domain of the following function and write the answer in interval notation. So again, we have an equation, so let's go through our rules. Rule number 1 deals with the denominator. It says whatever the denominator is, so this time our denominator is the square root of 2 minus x. We know that the denominator is not allowed to equal 0, so we're going to write that as the square root of 2 minus x cannot equal 0. And let's solve that. So I'm going to square both sides to start with. All right, when I square the left-hand side, that's going to eliminate the square root. So 2 minus x cannot equal 0 squared is just 0. To solve this, I'm going to add x to both sides. So that's going to give me 2 cannot equal x. And I like to write it as x cannot equal 2. All right, so that's the first step. Then we have step 2. So that's one piece. Let me go ahead and star that so we remember. Step 2 says if there's a radical in the problem, which there is, that the radicand cannot be less than 0. So we're going to write that as 2 minus x, because that's what the radicand is, has to be greater than or equal to 0. To solve that, I'm going to subtract 2 from both sides so you guys can see what's going on. That gives me negative x has to be greater than or equal to -2. But remember, I need to go ahead and solve for x. So I'm going to divide both sides by -1. Remember that when you divide by a negative, when you're solving inequality, you have to flip the inequality symbol. So that's going to leave me with x is less than or equal to 2. All right, so I have these two pieces that I need to put together to create the domain. So I'm going to write them up here. I have x cannot equal 2, and at the same time, x has to be less than or equal to 2. So let's think about what that's telling us. One of them is saying x cannot equal 2, and the other one is saying that x has to be less than or equal to 2. When I put those together, what that's saying is that x has to only be less than 2, okay? Because this one is saying that x has to be not equal to 2. So really, I'm eliminating this equal to part. So x has to be less than 2. To write that in interval notation, that's everything from -infinity up to 2, not including 2. So it's going to get a parenthesis.